In this video, we look at another application, this one involving filling an aquarium. It takes a hose 5 minutes to fill a rectangular fish aquarium, 16 inches long, 8 inches wide, and 10 inches tall. How long will it take the same hose to fill an aquarium measuring 48 inches by 18 inches by 21 inches? Let's start by drawing a picture. I have an aquarium that's 16 inches long, 8 inches wide, and 10 inches tall. So let me draw that aquarium and label the sides. I've got 8 inches wide, I've got 10 inches tall, and I've got 16 inches long. Now I'm told that a certain hose will fill this tank in 5 minutes. I'm asked how long it'll take using this same hose to fill a different size aquarium, one that's actually bigger. This one is 48 inches long, 18 inches wide, and 21 inches tall. So the picture becomes, I have a bigger aquarium. Now it's obviously not to scale, but it's just for reference to visualize it. And I have to fill this tank. And it's going to take a certain time. I don't know how long, but that's what I'm looking for. X minutes. It's going to be longer than 5 minutes, I know that. Where to begin? Well, I don't know about you, but the idea of proportions seems to ring a bell with me. We are filling one tank at a certain rate, and that hose fills at the same rate. And so we have a proportional relationship. Namely, the time it takes to fill the first tank is related to the time it will take to fill the second tank in the same rate. 5 minutes is to the size of the first tank, as X minutes is to the size of the second tank. Notice I use the word size. Size is important. Size has to deal specifically with either a length, an area, or a volume. And when we're talking 3 dimensions, as we are with a fish tank, the size we're talking about is a volume. I think what we need to do is set up a proportion then that compares minutes to a volume, specifically cubic inches, and then minutes to the second volume, cubic inches. Let me get that setup started. I want 5 minutes corresponding to so many cubic inches. So I'm just going to write down cubic inches on the bottom, and we'll fill that in a second. And that's going to be in the same relationship as X minutes is to another cubic inches, and we'll fill that in as well. But if we get those two values in the denominators, then we have a proportion and we can solve. So that's going to be our plan of attack. We begin by calculating the volume of that first fish tank. How do we get the volume of a rectangular box or a rectangular solid? We take the length times the width times the height. So for that first fish tank, if I want to take the length times the width times the height, and let me just clear up some space here and try this again. I want the length times the width times the height. I want 16 inches times 8 inches times 10 inches. And if I put that together into my calculator, I get 1,280 inches. So that means that this first fish tank has a volume of 1,280 cubic inches. I can use that number and fill that into the denominator on the left side of my proportion, 1,280. And we start by saying 5 minutes is to 1,280 cubic inches as X minutes is 2, and now let's calculate the volume for that second aquarium. That second aquarium has a volume, again, length times width times height, and that is 48 times 18 times 21. Pulling out a calculator and multiplying 48 times 18 times 21, we get that this volume is 18,144 cubic inches. So that will become the value on the right side of my proportion in the denominator, 18,144 cubic inches. My proportion, 5 minutes, is to 1,280 cubic inches, as X minutes is to 18,144 cubic inches. Now all we have to do is solve the proportion. 5 is to 1,280, as X is to 18,144. How do we solve a proportion? We cross multiply and divide. So let's take 5 and multiply it times 18,144. When I multiply those two numbers together, I get 90,720. Let me also multiply now 1,280 times X. That's just 1,280X. To finish, we divide. That means we divide both the left side and the right side by 1,280. That gives us X on the right side. And on the left side, 90,720 divided by 1,280 is just 70.875. What were we measuring X? X, recall, was measuring the amount of time it would take the hose to fill that second aquarium. Generally speaking, they're going to ask you to round to the nearest minute. So I'll just round to the nearest minute, and 70.875 then becomes 71 minutes. So it takes approximately 71 minutes to fill that larger aquarium. As with all these application problems, you may have solved this problem differently. My method is just one way of looking at the problem, but it does use our tool of proportional reasoning. If you have any questions, don't hesitate to reach out.